Hi everyone. Today let's look on another famous problem, which is converting Roman numbers to integers. Well, first of all, let's look what Roman numbers are. Here you can look on my paper to see that basically it is the way to represent numbers using letters, and there are this limited set of letters, which is I, V, X, L, C, D, and M. Well, you can see on the left is a map of these letters to integers. For example, I is 1, V is 5, M is 1000, and so on. Okay, so how can we construct numbers using these letters? So you can see on example 1, the number I is 1 plus 1 plus 1, which equals to 3. And on the second example, you can see that this Roman number VI, which is really 5 plus 1, which equals 6. On the third example, you can see IV, which is 5 minus 1 equals 4. So basically, algorithm is that if the current number is greater than the next one, we sum up to obtain integer. If current number is less than the next one, we subtract it from the next one. Okay, and we can calculate also big numbers like the one you see on the fourth example, like MCMLIV. So basically it is M plus M minus C plus L plus V minus I. And if you substitute these letters with corresponding integers from the map, you can calculate this integer, which is 1954. Okay, and basically it is the way that we need to write our program, calculating calculating basically letter after letter. We can do it from left to right and from right to left. Well, the difference is small. The interesting thing here that with Roman numbers, this notation, the maximum number we can represent is equal to 3999. Well, it means that basically it is the limit, it is the max number. So if we speak about time complexity, basically we can argue that the time complexity is constant, because we cannot go we cannot have a number that is larger than that. Okay, and basically we can keep only one variable to calculate the sum, which is a resultant integer. So the state here is also constant. Okay, so let's look how it works in a programming language, in a Python. So here we have input and we have expected number. So what we want is we want that we want to have some output, and we want this output equal to the expected, and let's print the output. Okay, so how to calculate the output? Let's have a class for this. Solution def Roman to int. Okay, we have this method which returns none for now. Okay, let's call it here to calculate output. Okay, let's execute it now, just to see that it works. Okay, it returns none. Good. Then now, how to convert this Roman number to integer? Well, first of all, when I showed you my paper, you saw this map of Roman letters to integers. Let's create that map. Roman nums, let's call it, and let's have this. So it is 1, 5 in terms of integers, 10, 50, 100, 500, and 1000. Okay, so 1 is equal to I is equal to 1. So this is V is 5, X is 10, 50 is really L, right? 100 is C from cento, okay? 500 is D, and 1000 is really M, mille. Okay, so we have our map. Now let's okay, to calculate it, we basically need to have only one state. We can define here like result, and let's map from the right to left. In this case, we need to track less things. We should init our result to the last element of the input, which is V. Okay, but let's convert it straight away to our integers. So we call our Roman nums. Okay, and now we need to loop from the element which is the one that is previous to the last one from the I, and basically to decide, do we need to sum it up to the previous element or to subtract it. So let's do it. For E in reversed range len input -1, because not from the last one, we calculate, okay, current is equal to Roman nums input I, and the previous equals to Roman nums input I minus 1, I plus 1. Okay, so, and here we have our condition. So if basically current one is if current one is greater than the previous, it means that we need to sum up. Else we need to subtract. Okay, basically we keep looping, iterating over elements and doing sum up, sum or subtraction, and in the end we need to return result. Okay, let's check. Does it work? Yeah, it works. True, we have a number. So now let's check how it looks like with the debugging in a state. So let's put it inside tutor. Okay, basically you see that we initialized our dictionary or our map of letters to integers, which is I, V, X, L, C, D, M. Basically this means that the space complexity of this solution is constant because we initialize this new map, but it has a limited set of keys, only 7. So we can say that it is a constant space. Okay, so here you see that result is initialized to the value of the last letter, which is 5. V equals 5. You see from our map, V equals 5. Okay, so and we keep iterating from the element which is previous to the last one, which is I, starting from this element. Well, you can see the current is 1, which is equal to I equals to 1 in our map. Okay, we got our current, and we got our previous element, which is 5, because v is 5 in our map. Okay, so basically we decide if current 1 is bigger than prev. No, it is not bigger, so we need to subtract, and you see the result is 4 already. Okay, let's go to the next iteration. Okay, so current 1 now is 50, and the previous is 1, because we are on the letter L now, and letter L is 50. Okay, so basically current 1 is bigger than, it means that we need to sum up. Okay, we sum up. Next iteration, the current 1 in 1000 is, the previous is 50. Again, we are on the letter M, and you see letter M equals to 1000 in our map. So current value is greater than the previous, so we need to sum up. We sum up. The result now is 1054. Okay, going on to the next element, and the next element is C, which results to 100 in our hash map. So basically current 1 now is 100, and the previous, which is M, is 1000. Current 1 is less than the previous. It means that we need to subtract. Okay, so we have 954 result, and the last element is M, which is 1000, and it is the current 1, and the previous is C, which is 100, and the current 1 is greater than the previous. It means that we need to sum up. Okay, and here the result is 1954. Okay, that's it. This is our result, and as you can see, as I already told, the spacing complexity here is constant, and also time complexity is constant here, because yeah, it looks like it should be, this time complexity should be linear, because you keep iterating over each symbol of the Roman number. But I remind you, the maximum number that can be represented by this notation, Roman numbers notation, is equal to integer, which is 3999. So it means that we basically cannot go over than 9 characters. So the limit of characters is 9, and well, it means that the time complexity is really constant here. Okay, well, that's it. Thank you for your attention. See you the next time.